Hi, I'm Mrs. Edwards. Last lesson, we found the sum, difference, product, and quotient of a couple of functions, and then we found the resulting domain. This time, we're going to find composition functions and then determine their domain. Here we have our first example. We are given a function f and another function g, and we want to find f composition g of x. Another way to write that is f composition g of x. We want to start with the f function, so I want to start with 2x plus 5. However, every place that we see an x, we want to replace it with g of x. Notice normally you would see f of x. So instead of f of x, that x is getting replaced with g of x. So I'm going to replace the x in the f function with g of x. And we actually have now found the answer to f composition g of x. Next, let's evaluate the composition at the number 6. So to find f composition g of 6, we can go to our composition f comp g of x right here, 2 root x plus 3 plus 5, and just substitute 6 into that. And if we simplify, we end up getting 11. There is more than one way to evaluate f composition g of 6. Here is a second way to do that. You can just do what's inside of the parentheses first. So I could just find g of 6. So coming up here to the g function and replacing the x with 6, I would have 6 plus 3, which is 9, the square root of 9, which is 3. So the answer to g of 6 is 3. Next, I'll find what is f of 3. So if I substitute 3 back into the f function, I'll have 2 times 3 plus 5, and we get 11. Notice we got the same answer two different ways. One method is you find the answer to the composition and then substitute 6. The second way is to rewrite f composition g of 6 in another way using a different type of notation, and then we can just evaluate the g function at 6, get an answer, and evaluate the f function at 3. Before we move on to finding the domain of f composition g of x, I just want to point out that f composition g of x is not the same as g composition f of x. If I were to find g composition f of x, I would have started with the g function, square root of x plus 3, and replaced that x with the f function. So that x would have turned into 2x plus 5. So there is no commutative property here. So just want you to make sure you know f comp g is not the same as g comp f. Let's now find the domain of f comp g of x. We already found the answer to f comp g of x. We also happen to find that the answer to f comp g at 6 was 11. I'm bringing that over just to remind you that we substituted 6 into the composition and we got out an answer. So that means the number 6 is in the domain of the composition function. Domain means the numbers that you can substitute into the function and get out real value answers. So let's go ahead and find all the numbers that we can substitute into f comp g of x and get out real value answers. The rule for finding the composition's domain is you want to consider the domain of the input function and the domain of the answer to the composition. Let's begin with the input function. The input function in this case is g of x. So I want to find the domain of g of x. To find the domain, you're looking for three main things. Is there an x under a root? Is there an x in the denominator? Or are we taking the log of x? If the answer to all of those is no, well then the domain is all real numbers. In this case of g of x, there is an x underneath that square root. So since there is, we're going to immediately set that x plus 3, what's in the radicand, what's underneath the root, greater than or equal to 0. That ensures that we're only going to use numbers that when we substitute them in, we won't end up taking the square root of a negative number. Solving that by subtracting 3 from both sides, our inequality gives us that we can use numbers -3 and bigger. Next, we want to find the answer to, we already have the answer to f comp g, but we want to find the domain of the answer. So we're going to be finding the domain of this function up here. Similarly, if we're finding the domain, we're looking for x's in the denominator, x under an even root, or the logarithm of x, and the only feature this equation has is an x underneath the root. So to find the domain, you set the radicand greater than or equal to 0. So x plus 3 is the radicand, and when we solve, we get the exact same answer. To find the domain of the composition, we want to merge those two together, but they're exactly the same. So since they're exactly the same, the domain of f composition g of x is bracket -3 through infinity. That's just our interval notation saying that yes, we can use -3, we have a bracket, and then all the numbers to the right on the number line, so through infinity. Let's look at one more example of this kind. We're given f and g, and we would like to find f composition g of x. That's the same thing as f composition g of x, just writing it a little bit differently. We want to start with the f function, and so I'm going to start with x squared plus x plus 5. Here we have that, but I've just put a set of parentheses every place we see an x in that original f function. Next, we're going to substitute g of x into the f function, so every x in that f function is turning into all of g of x. Lastly, I need to simplify, and I'm going to be squaring a square root. So this one is just going to be x squared minus 16. We still have plus the square root of x squared minus 16 plus 5. I'm going to simplify just a little bit. -16 and 5 make -11. And that is our final answer for f composition g of x. Please don't accidentally make this right here x minus 4, danger. That is not true. X squared minus 16 factors to be x plus 4 times x minus 4. You can only pull out two of a kind, comes out front as one thing if they're exactly the same. So just careful there. All right, then let's move on. Now that we've found the answer to f composition g of x, let's evaluate it at x equals 6. We'll take the answer we got to the composition and substitute in 6. So I have written out the composition function that we just got, but I just left room for the x's to be substituted with 6. All right, I'm going to slide in those 6's and start simplifying. Simplifying at the start here, 6 squared is 36. And here we have 6 squared is 36 minus 16, which is going to be 20. All right, then we can combine 36 minus 11. The plus root 20, we want to simplify that. Little quick reminder, 20 is 2 times 2 times 5. So we have a pair of 2's, so we can take a 2 out front. And we end up with plus 2 square root of 5. So the answer is right around maybe 29.5-ish. Okay, we could find the answer to f comp g of 6 a different way. Here, notice we used the answer to the composition. We had the equation for f comp g, and then we substituted 6. But if I didn't have the equation, if I hadn't already found the f composition g of x equation, we could instead think of it, the f comp g of 6, using this notation, f composition g of 6, and then do what's inside parentheses first. So I want to evaluate g at 6. So I go up to the g function and I replace the x with 6. And if you do that, you're going to have 6 squared minus 16. And then we get the square root of 20. Now that we have the answer to the g function evaluated at 6, I can now evaluate the f function at the square root of 20. So if I substitute in root 20 into the f function, I have that. Root 20 times root 20 is 20 plus root 20 plus 5. We simplify that and we're going to get the exact same answer. Now that we have found the composition of f comp g of x, let's go on to find the domain of f comp g of x. Here's what we had for f comp g of x. We did also find f comp g evaluated at 6, which did have a real number solution. So we do know at least 6 is in the domain, but let's find all of the numbers that are in the domain. To find it, we're going to first consider the input function. So our input function here is the g of x. So let's look here at g of x, and we would like to find the domain of g of x. As soon as we're finding domain, we're thinking, okay, I'm looking for an x underneath an even root, I'm looking for an x in the denominator, or a logarithm of x. The only characteristic that g of x has is an x underneath the even root. So we're going to take the radicand, which is everything underneath that root, and set it greater than or equal to 0. Solving this inequality is more work than the last one because the exponent on x is 2. Anytime we have an exponent greater than 1 and we're working with an inequality, we're going to need to find critical values. In other words, you simply replace the inequality with an equal sign, and then you solve this mini equation here. So if I add 16 and square root both sides, I will get both positive and negative 4. Those are my critical values. They go on a number line. And then we need to test numbers around these ones to see if it makes the x squared minus 16 greater than or equal to 0 true or false. I'm going to start by testing negative 5. So if I substitute negative 5 back in there, negative 5 squared minus 16 is a positive number. A positive number is greater than or equal to 0. So every number to the left of negative 4 will make the x squared minus 16 greater than or equal to 0 true. Now let's pick a number between negative 4 and 4 and test that one. I'm going to go with 0. If I substitute 0 into the x squared minus 16 greater than or equal to 0, I end up with negative 16 is greater than or equal to 0, which is not a true statement. That means that every number between negative 4 and 4 is not going to make that true. So we can't use those numbers. Let's pick a number to the right of 4, any number we want. I'm going to go with 5. Substituting 5 in here, I get a true statement. 5 squared minus 16 is greater than or equal to 0. So that means every single number that I substitute to the right of 4 into that x squared minus 16 greater than or equal to 0 will make that true. So the domain of our input function, those are the numbers that make x squared minus 16 greater than or equal to 0 true. So we have the section to the left of negative 4 and the section to the right of 4. But negative 4 and 4 also work, those numbers themselves, because when I substitute negative 4 or 4 back in here, I'll get 0 is greater than or equal to 0, which is true. So the numbers that we can use are negative infinity through negative 4, including negative 4, and then the number 4 through infinity. Next, we want to consider the domain of the answer to the composition of f comp g. So in other words, we want to find the domain of x squared minus 11 plus the square root of x squared minus 16. In finding the domain, we want to look to see, do we have an x under an even root, an x in the denominator, or are we taking the logarithm of x? This f comp g of x function here, the only feature it has is an x underneath an even root. So we take the radicand, which is x squared minus 16, and set it greater than or equal to 0. Notice we end up solving the exact same inequality. So since we've already done the work, we know that the answer to this one is the negative infinity through negative 4, union 4 through infinity. When we want to find the domain of f comp g of x, we're going to take the domain of the input function and the domain of the answer to f comp g, and we're going to merge the two. But because they're exactly the same thing, that is our final answer for the domain. We're going to now tackle one more concept. We want to write two functions defined implicitly when we've been given this relation x squared plus y squared equals 25. All right, first of all, just a little vocabulary. Notice that this equation we've been given, x squared plus y squared equals 25, has been called a relation and not a function. So it means that x squared plus y squared equals 25 does not pass the vertical line test. But we're going to rewrite it using two functions. So each one of those will pass the vertical line test. And when we write both of them and graph them together, we're going to end up getting the graph of x squared plus y squared equals 25. Defining a function implicitly just means that you want to solve for y. So let's go ahead and solve for y. I'm going to subtract x squared from both sides. Next, I'm going to take the square root of both sides to get y by itself. Do not forget, every single time you decide to take the square root of both sides, you get positive and negative. So what we have here is two separate equations. So our two functions are y equals the square root of 25 minus x squared, and our other function is y equals negative square root of 25 minus x squared. What we want to do next is graph them both. So let's head over here to Desmos.com real quick. Here we are at Desmos. Notice I have entered in each one of these equations. The positive square root of 25 minus x squared, it graphed this top half, and then the negative square root of 25 minus x squared graphed the bottom half. Taken together, that's going to be the equation of x squared plus y squared equals 25. Just a little quick reminder on Desmos, down here at the bottom, you can click this keypad and then you will find there a square root. That will allow you to enter in these functions. So one more time, if I want to graph x squared plus y squared equals 25, I graph each one of those separately. And when we did that, we ended up with a circle. X squared plus y squared equals 25 is the entire circle, and it does not pass the vertical line test. But each one of these separately is a function. The green one is a function and the orange one is a function. If you have a y squared in an equation, it's going to take two equations for you to graph that equation.